Hi, welcome to this talk on how to build a social network in under 4 weeks using Serverless and GraphQL. So I recently worked on a client project where I built a backend for a new social network that lets you find people to do sports with, and it supports instant messaging, group chats, and other common social network features. Users can also use the app to book classes and courses for sports that are offered by their universities. So the client is a privately funded, bootstrapped startup, so there's a lot of constraints on money and therefore development time. And they need something done quickly in time for university semesters to start again now in September. So in terms of the goals of the project, it needs to be done quickly, but it still needs to be able to scale to millions of users if it takes off. Right away, it's going to get rolled out to tens of thousands of students in Belgium, and then to other countries after that. It needs to require minimum upkeep because the client can't afford a full-time team to look after this, so it pretty much needs to run itself and not fall under. It also needs to be cost efficient as well, even as we scale to millions of users. So the project was put together with a small team of 3 engineers, including myself, in just a few weeks. And we didn't just build a new mobile app, we also built a CMS for the app as well, which will be used by the founders to onboard new universities and also used by the university admins to manage their profile and to publicize and configure their sporting programs so that students can book classes and book tennis courts and so on. So I'm not going to show you the full architecture, but there are a few of the key components here where we have CloudFront and S3 for image assets and such. And for authentication, we use Cognito. There's one Cognito user pool for the mobile app, and then another one for the CMS. So the whole backend is done in the GraphQL using AppSync. Again, one for the mobile app and the one for the CMS. And they each have resolvers that point to DynamoDB tables for simple get, put, and query operations. But for anything more complicated than that, I have a Lambda function resolver. And that function will probably do something against DynamoDB tables as well, but typically more complex operations like transactions or batch read and batch write. I mean, you could do a lot of this using pipeline resolvers instead of Lambda, but I find it easier to do that with Lambda, and also it will be easier for me to hand it off to somebody else later who can understand JavaScript code rather than someone who have to read and write BTL. And we also use Algolia for search. And Algolia is probably the closest thing you're going to find to a serverless Elasticsearch. So to get the data into Algolia indices, I use the DynamoDB streams to trigger Lambda functions to synchronize any data change to Algolia. So whenever a user creates or updates their profile, or they start a new sporting activity in the app and look for people to join them, those are all going to get synchronized to Algolia. And I also capture BI or business intelligence events from the different Lambda functions and use a Firehose delivery stream to buffer and batch them into S3. And so I can run BI analytics and the reports against them in the Athena. Again, this is not the architecture diagram per se, but it's a summary of the different services I used and how they all fit together from a very high level. So remember, all of this was done by one person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants, and I can use really good tools like the Server framework to help me manage and deploy my application. So my name is Yan Cui. I have been an AWS user for a very, very long time, and I've been running production workloads at scale on AWS for over 10 years. And since 2018, I have been an AWS Serverless hero. And the last couple of years, I've primarily focused my efforts building stuff using serverless technologies, including in 2016, I worked for another social network, and I migrated them to an entirely serverless architecture as well. So you can read about that particular journey in the link down at the bottom of this slide. So nowadays, I spend half my time working with Lumigo as a developer advocate. And the Lumigo is a troubleshooting platform for serverless applications that make it a lot easier for you to debug any problems you have for your serverless architecture, including performance, as well as any errors you see in production. And the other half of my time, I work as an independent consultant, where I help clients all around the world go faster by adopting serverless technologies through trainings, through advice, or maybe like this particular client, I help them build the actual product. I also run a weekly podcast called The Real World Serverless, where I speak with other builders to talk about how they are using serverless technologies to improve their business. And I also have an upcoming video course on AppSync called AppSync Masterclass, where I teach you GraphQL and AppSync by building a Twitter clone using AppSync, DynamDB, Lambda, Vue.js, Amplify.js, and so on. So in terms of what is AppSync, it's basically a managed GraphQL server that lets you map those query and mutation operations as well as your data types to different resources in your AWS account. And it supports DynamDB, Lambda, Aurora, and Elasticsearch, as well as just HTTP endpoints out of the box. So AppSync itself is very scalable. And they also have a GraphQL subscription implementation that can support millions of connected clients. And your AppSync API is deployed to multiple availability zones out of the box. So that also gives you a great baseline for resilience. And you only pay for what you use at the $4 per million operations. And it also supports caching out of the box, which does charge you extra, but essentially you're going to be paying for uptime for a memcached node, and the cost per hour is depending on the size of that node. It also has a built-in integration for monitoring with CloudWatch and the CloudWatch logs, where you get high-level metrics like number of API requests, error count, and latency, which is great, by the way, but unfortunately, all of these metrics are aggregated at the API level. So it's difficult to tell which resolver is causing any performance problems, since a single query can involve many resolvers, as we know. Luckily, you can also enable logging, which then gives you a lot more information about what's going on. So you can at least narrow down to specific requests that maybe took a long time, and you can then inspect the resolver logs for what that request is doing and to figure out what the problem was. For performance issues, I still prefer to enable X-ray on the AppSync API, which really shines a light on what's happening under the hood, and it shows you where the time is taken. And you can see that this single query has resulted in quite a few DynamDB calls behind the scene. And X-ray also shows you a service map, so you can get a high-level view of which services your AppSync API is talking to and the overall health and the latency and performance. And it gives me all of that, and I don't have to manage any servers, which is just great. So in general, I find the developer experience with AppSync has been really superb. And everything has worked well, and I haven't run into any major problems. In terms of authentication, as I mentioned earlier, we use a Cognito user pool, and I've set up identity federation so that users can also sign in using Facebook and the Apple account as well. So on the client side, we use the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as the authentication is concerned. However, I didn't use the AppSync CLI to create and configure the Cognito user pools themselves. I did it with the serverless framework and with CloudFormation. In general, I think the Amplify CLI hides too much important details about how your system is configured, information that you really should be more familiar with if you're going to be looking after this system in production. Amplify can provision and configure the DynamDB tables and AppSync resolvers for you. You can do a lot of this using CodeGen, but I don't agree with some of the decisions it takes. For example, how it defaults to using DynamDB scans for list operations. And in this particular case, the DynamDB schema and access patterns are really important, with potentially huge scalability and cost implications. So I want tighter controls around that, and I need to understand my access patterns intimately. The CMS also uses Amplify.js to authenticate users against the CMS Cognito user pool. The founders can use it to onboard new universities and invite the university's admin staffs to the CMS. Behind the scenes, we will have a Lambda function create a user for the university admin in Cognito and then add them to the university group to identify them as university admins. And we use a custom attribute to tell us which university they are the admin for, which is then passed along to our backend or the AppSync resolvers by Cognito when the user interacts with the CMS AppSync API. At no point does the client actually pass the university ID to the backend and say, hey, trust me, I'm the admin for this university. Just let me have access to the data. No, it's always based on your identity that's been resolved by Cognito. So when you're the university admin, you see a different set of options in the CMS UI, which are limited to just your university. The nice thing with AppSync is that you can restrict access to operations using Cognito groups. So if you are an admin, you'll be able to get university details by name, and you can edit the sports we have in the app and so on. But if you are the university admin, then you can only fetch and edit information about your university. And if we don't specify any specific auth option here, then any logged in users can perform those actions, like getting an upload URL for images and so on. So moving a bit closer to the code, I use the server framework to help me package and deploy the application. So in this case, I've got one repo for the whole backend, and everything is configured in one Serverless YAML and is deployed as one CloudFormation stack. So resource reference and all that were very straightforward even as the project grew. And to deploy, I had just one command I need to run, serverless deploy. So to make it easy for me to configure all these resolvers that I had with AppSync, I'm super glad that this Serverless AppSync plugin, which really makes things easy for me. And as I mentioned, since we have two AppSync APIs, one for the app and one for the CMS, I broke those out into their own files so that things are a bit tidier and more manageable in the main Serverless YAML. And each of these files is going to look something like this, where I hook it up to the right Cognito user pool, and I configure logging, where in production, we don't want to log everything because it generates so much logs to CloudWatch, and it's going to add just a lot of noise, but also there's going to be a cost associated with that as well, since CloudWatch logs charges you 30 cents per gigabyte ingestion, and then also 3 cents per gigabyte per month for data retention. And then I will configure my resolvers and the data sources in the same file. For many of these resolvers, we will go straight from AppSync to DynamoDB. So the request and response have to be written in the Apache VTO, which is the same templating language that API Gateway uses as well. So I'm kind of familiar with it already. And honestly, I think the official documentation for AppSync does a pretty good job and gives you a bunch of examples that you can just follow. So most of the time, I'm just using their examples and then I'm tweaking it to meet my actual needs based on the table designs I've got and the operations I'm doing. And as the project grew, I also hit the 200 resources limit pretty quickly, since I also try to follow security best practices and apply the principles of least privilege and have one IAM role per function. So it didn't take me very long to get up to 200 resources. Luckily, there's the split stacks plugin, which can split your one stack into multiple stacks by splitting some resources into nested stacks instead. And the great thing here is that it also lets you control the splitting logic yourself, which was very handy as I had several iterations around how I split those resources to allow the project to just keep growing as more and more features are added. Which at the time of writing, the project has over 200 resources across the two AppSync APIs, and it has a total of more than 600 CloudFormation resources as well. In terms of CI/CD, since the whole code base was in GitLab, I decided to use GitLab CI/CD. And one technique I've employed in most of my projects is to install the serverless framework as a dev dependency in the project, which means I don't have any extra dependencies on the CI server. And I can add a simple helper script in my package.json to run this version of the server framework that's installed in the project. So when it comes to deploying from CI, it's literally a two-step thing. To run npm CI, which restores my dependencies to the exact version as they are in the package.json, and then run npm run sls deploy to trigger deployment using that version of a server framework in the project. And of course, we also want to run tests in the CI/CD pipeline as well. And when it comes to testing, one of the challenges with using something like AppSync is that it's a black box. So how do you test it locally, right? There are tools that let you simulate AppSync locally, but I generally don't bother with them because they don't cover everything, including IAM policies, and honestly, those VTL templates are so simple, they just work. Where things tend to go wrong is in my Lambda functions, where I tend to do more complex things. So for those, I like to test my integration with other services like Algolia or DynamDB by executing the function locally, but talking to the real DynamDB table or Algolia. I don't tend to use any mocks or stubs or simulate them locally with things like local stack, which I find just takes too long to set up properly, and they're also quite brittle and breaks easily. It's just easier for me to provision the tables in AWS and use them in my integration tests. And I also have end-to-end tests that run user stories, like creating a profile, doing a search for other users, and then joining another user's activity, and so on. And I'll run this end-to-end test against the deployed GraphQL endpoint, so this will always be run after the deployment. And if you have any failed end-to-end tests, then great. Use this as a valuable rehearsal for how to debug problems in production. If it's difficult, then guess what's going to happen when you've got a problem when the system is live with millions of users using it. Use that as a signal that you need to improve your logging, how you're monitoring the system, and enable extra tracing and so on. If you struggle to debug problems in a controlled environment like your end-to-end test, then you're going to have a much bigger problem when this thing is running in the wild. So don't optimize for your comfort with things like local simulators. It's a false sense of security. With AppSync, Lambda, and DynamDB, our entire stack is pay-as-you-go and serverless, and the cost per million requests is just a few dollars. So the projected cost for this when we go live with tens of thousands of users is going to be really small and well covered by the AWS credits we get through the AWS Activator program. And that brings me to the end of this talk. Thank you guys so much for your attention and for being with us today. As I mentioned earlier, I spend most of my time as an independent consultant, so if you want to see how serverless can help your team go faster, or you just need some help upskilling your team, then let me know. Go to theburningmonk.com to see how we can work together. And finally, I want to remind you about my upcoming video course, the AppSync Masterclass, where you can learn GraphQL and AppSync by building a Twitter clone. So again, with that, thank you very much and enjoy the rest of the event.